questions. Once again, should be fairly similar to what we did last year. Should be review. So, oops, I skipped one, so we'll go back. It says for f of x equals x squared plus 7, evaluate. Now notice I could evaluate it for anything. So if I just put a single number in there, I could evaluate it that way as well. But since we've done that so many times, I'm not going to look at those. We're going to look at these two instead. So remember, when it says to evaluate, what I do is I'm going to put the 3a wherever I see the x. So in this case, I'm going to take 3a quantity squared plus 7. What does that give me? 9a squared plus 7. And that's it. You can't do anything more. There are no like terms. You can't simplify it any. Now the next one, on the other hand, though, has a quantity, n minus 1. So once again, I'm still going to take that n minus 1 and I'm still going to plug it in for x. So I've got n minus 1 quantity squared plus 7. Now when you square that quantity, remember what we need to do? We need to make sure we FOIL that out so we don't miss our middle terms. What does that FOIL out to be? N squared minus 2n plus 1. That's what all of this multiplies out to be. And then you still have your plus 7. So your final step is to locate any like terms that you have. And the like terms that you have are, right? So you get n squared minus 2n plus 8. There you go.
Where did you get n from? N minus 1 and n minus 1 squared.
Because remember we talked about that on Friday?
No, I know that. But how did you get from the f of n minus 1?
Because I'm plugging in n minus 1 for this. Okay. Alrighty, so that's the functions. You're subbing them in, you're solving them. Pretty straightforward. So now we're going to talk about the domain and the range. So what we're going to do to find the domain and the range, okay, on these, there's two ways to do this. One, we can graph them, or two, we can do these algebraically. I would probably recommend that you graph them. So go ahead, get out your graphing calculators. Where do you go to graph?
Y equals.
Y equals. So the y equals at the top left. Okay, so then now you're going to take the square root of the quantity x minus 1. So go ahead and type in square root quantity x minus 1. So what's going to happen is you should have the square root, parentheses, x minus 1.
Where's the x again?
The x, remember, is located by the green alpha key. It's the x, t, theta.
Mine said theta.
Okay, because yours is in a different mode than just I'll change your mode for you. There you go. Okay, so does anybody not have the x? Okay, so when you go ahead and get done with that, go ahead and hit graph. Okay. So, okay. So then now what's going to happen is if you have a different window, a good rule of thumb is always to go to zoom standard, which is the 7. Okay? The zoom and standard, or it's Z standard. And so if you notice, what does this graph look like? Where does it start at?
It starts at
Found it.
1, right? Does it include 1 or not include 1? It includes 1, right. Now, if you wanted to know if it includes 1, plug 1 in. And if I plug 1 in here, I get square root of 0, which the square root of 0 is 0. And then the graph looks something like this. So now I need to tell what the domain and the range are. Remember, the domain is the set of x values. So that's your horizontal. Okay? So horizontally, where do I start? Where does it start here on the graph? 1, right? So do I include 1 or not include 1?
You include it.
So then I use a bracket. This is that interval notation that we learned the very first section of pre-calc. And then where do I go? infinity. And here I use a parentheses because remember, you never use a bracket with infinity. So there's your domain. The range, that is up and down. So what is the lowest one?
0.
0. Do I include it? Yes, since I already wrote. And then I go there to infinity. There you go. That's your domain and range. Okay. Should be reviewed because we did this last year. Okay, let's look at another one. Find the domain and the range of the tangent of x. Okay, so go ahead. Now, you need to make sure that you are in radian mode. So you need to go to mode and make sure you're in RAD, not DEG. Make sure you're in radian mode. Y equals? Now, if you want to go to a good window, on that one you could go to Z trig. Excuse me, Z trig. So if you aren't getting a good picture, go to zoom and go to Z trig, which I believe is the 7th one down. So then now what's going to happen is when you look at this, you're going to get something that looks like this. And so what ends up happening is you have a bunch of asymptotes. Okay? You have a bunch of asymptotes in here. Now these asymptotes are periodical, which means they occur at specific points. Now, does anybody happen to have your sheet from last year, was it cute sheet? Do you have that on you right now? I do. Okay. So then now, if you look at tangents, where were the values of tangent undefined? 90 degrees or pi over 2. Now if you remember, see that's why that chart's handy, because it tells you where that's undefined. And it's undefined, remember that's where your asymptotes occur. So in looking at this, your asymptotes are going to occur at a difference of 180 degrees. So our next one would be like at 450, and that's how you keep going. And so now what we need to do is we need to find our domain and our range here. So our domain is a little bit funny, because when you think about that, we know that the domain, in this case, starts at 0, then it goes to 90, and then it stops. And then it goes from like 90 to 270. And so if I notice, and by the way, we need to write this in radians. The reason why we're looking at degrees is because it's a little easier. I'm going to look, what's the difference between these two? 1 pi, right? So basically, if I start with pi over 2, if I start with pi over 2, if I start with pi over 2, and I add or subtract pi, would that be true? Okay, what I'm going to do now is I'm going to put an n in there. Now what that n is going to mean is any number. And so let's think about what I just did. N means any number, so that could be 1 pi, 2 pi, 3 pi, 4 pi, negative 1 pi, negative 2 pi. That n, e, remember n is an element of the integers. That tells you what values you can plug in for n. And so if you have a situation like this, where you have a trig one, this is what you're going to write. Something to this effect. And that'll take some time. We're going to be working on this throughout the year. So if things still aren't real crystal clear, that's okay, but we have to start somewhere. Okay, our range. What's our range going to be vertically? Yeah, that's going to be negative infinity to positive infinity, right? Because there's no limits. It's every real number. Now, I'm going to warn you, these trig ones are a little tough. So like I said, if things are still a little fuzzy, it's okay. We'll get through it. No. In this case, you're actually using words. If you used the interval notation on this one, it just takes a little more. It's easier to use words here. Okay, we have one more thing we're going to look at today, and that's composite functions. Okay, we looked at this last year, so once again, should be nothing new. This is just review. And so the f is cut off. This is actually f of x here. So yes, that was the last and third thing that we had on the first slide. And so f of g, remember what that little o means, is that little o just means this. Okay, that's all it means. So then now, order of operations states you always do what? First. Parentheses. So I'm going to replace g of x with what? Cosine x. So I'm going to let you get that down and look at that and see what I did. So all I did is replace g of x with what the g of x function is, cosine of x. And then now it's just a problem like what we looked at on the very first slide. What do I do with the cosine of x? Where do I place that? Where the x is in the f function. So what will it be? There you go. That is what f of g is. Is that ringing a bell from last year? We didn't look at this. Okay, next one. What will that be? That's going to be g of f of x. So basically, you're going to kind of do the reverse. So now I'm going to replace f of x with what? 2x minus 3. Then what am I going to do with the 2x minus 3? Oh, wrong color. Let's try another. There we go. I'm going to plug it in for this right here. So my answer will be cosine of 2x minus 3. And your 2x minus 3 does need to be in parentheses. And if it's not, you're not going to get full credit. Okay, so make sure that 2x minus 3 is in parentheses. Okay, so far so good? All right, here you go. This is in your next section. I need you to do 3 through 11, the odds, 13, 14, 17, 18, 29 through 34, and 59 through 62. Remember, probably do Wednesday.